which is with the equation of angular momentum, L equals r cross p, and then I took the derivative of it, and since it's a cross product, I use the product rule, which holds for cross products. And then for this momentum here, I change that to m times r dot, and then these r dots cross each other will be 0 because they're parallel. So then you just end up with L dot equals r cross p dot, and p dot is the same as f. They get L dot equals r cross f, which is equal to the torque. And now since the torque is related to force and it's analogous to it in our regular momentum, if torque equals 0, then momentum is conserved. So L dot equals 0, which means that L is constant. So r cross p equals some constant. And that's useful for planetary motion because the force of gravity from the sun to the planet is in the anti-parallel direction, so that means that the force is 0, and that explains why the planets will speed up a little bit when r gets smaller, because since it's r cross p, p will have to get bigger, meaning the velocity will get bigger to compensate for the loss in radius. And along the same lines, it also helps to prove Kepler's law. So Kepler's law says that the area swept out by the orbit of a planet is the same at all points in its orbit. So this area swept out when it moves from P to Q is the same as when it moves from P prime to Q prime. So A1 equals A2. And to prove this, I just found the change in area of just P to Q. And so you estimate it as a triangle. So it's 1/2 base, which is V dt, times height, which is r. This r right here that I didn't label. And then if I multiply V times m, I have to divide by m out here to compensate for it. You get r cross 1/2m times r cross p dt. You know that r cross p is momentum. So you get momentum over 2m times dt equals dA. And so dA dt equals L over 2m. And since we know that L is conserved, it's constant, means that dA dt 1 is equal to dA2 dt. And just another application of angular momentum explains why figure skaters, when they spin, they start with their arms out and then they pull them in and they get faster.